anybody have snow this morning? We had some, but it's all melted now. Just a tiny amount, I reckon. If I'd scooped it all up in our garden, I could have made a snowman about this big. Who else has got snow? Well, welcome to our second session looking at polar regions. It's a really great development looking at understanding and learning more about climate, which is what we looked at last term rather, and also lots of opportunities for developing geography skills for older learners. And today what we're going to be looking at is we're going to be looking at a particular case study. So if you ever do GCSE geography and you're looking at any particular theme, so for example, earthquakes, you would look at a particular case study of an earthquake. If you were looking at volcanic eruptions, a particular example of a volcanic eruption. If you were looking at coastal erosion, you might look at the Holderness coast. Today we are looking at polar regions, and we are going to be looking at a case study. So we're going to be looking at a particular place, and we're going to be understanding and developing a little bit further, building on that knowledge from last term on climate, to understand a little bit more about the polar region. So hello to everybody. Some people didn't get snow. Not many people, which is quite surprising because I'm quite far down south. But hello to everybody: Grace, Rose, Jack, June, Peter, Lucy, Gethin, Alicia. Oh, somebody else had snow. Good, not just me. Only a teeny bit. But yeah, let's get started. So as I said, we're going to be looking at a case study, and we're going to be looking at Svalbard. And Svalbard is often known as the land of the midnight sun. Now, this photograph is of the Northern Lights. Supposedly last week, if you were in certain places in the UK, you could see the Northern Lights. I didn't see any where I was. But Svalbard is known as the land of the midnight sun. What do you think that means? A midnight sun? That sounds a bit odd, doesn't it? Because the sun definitely isn't up at midnight. So when I go to bed, if I woke up at midnight, I certainly wouldn't see the sun shining. So why do you think Svalbard is known as the land, and all the other areas around it are known as the land of the midnight sun? It's a bit curious, isn't it? It's a bit strange, do you know? So we're going to look at that a little bit more today. So this is a picture that's taken from Svalbard. So Svalbard is actually a collection of islands. If you want to get your atlas out, it is about 79 degrees north, or if you've got a globe that has latitude lines on it. And it's in the Arctic Circle. Now, if you remember from last week, we talked about the fact that the Arctic Circle contains lots of different places from lots of different countries, and it's a bit different from Antarctica. But this is a photograph taken from Longyearbyen, although I may not have pronounced that correctly. But this is the middle of the day, which is again a bit curious. The sun hasn't risen during the day at all. The people here, in fact, won't see the sun for another 4 months. So that's almost the opposite of what we've just said, isn't it? We've got somehow midnight sun, so saying that the sun is around at midnight, and yet here we have a picture that's in the middle of the day and it's all dark. It's a bit curious, isn't it? Really, really odd. So what I want you to think about is 5 questions that you could ask about this photograph, because this is a really good thing whenever you have a historical source or a geography source, a piece of information, and it seems a bit odd or strange, or you don't understand it. The best thing to do is think about some questions that you could ask. And so we've got who, what, why, where, and when, the W questions. So can you think of 5 questions you might have about this photograph? And I'm going to turn my camera off so you can see a little bit better. But what questions might you have about this photograph? Why what? Why what? What would your question be? Now you can see, if you look really close, you can see the moon. Even though it's the middle of the day, you can see the moon. You can see lots and lots of street lights. So who lives here would be a good one. What do people wear to keep warm? Absolutely, because it does look a bit cold. It's curious, isn't it? Who lives here? Absolutely. Looks like just a normal street, doesn't it? If you look really closely at the houses, they don't look much different to houses anywhere else. So really quite interesting. So someone's just said, yeah, how do the shops get food delivered? Do you think the picture's pretty? When does it turn light for them? When it's summer in the Arctic Circle, the sun doesn't set completely. Yeah, we're getting closer to some answers, which we're going to look at today. So lots of really curious questions. So well done to you. So has anyone actually heard of Svalbard? Well, the first thing to do, actually I might take my camera off again because you can see a bit better. But if you look here, you can see the circle, and this is where Svalbard is. So you can see back to that Arctic Circle, we've got the Arctic Circle, we've got the Arctic Ocean, and remember during certain parts of the year, we have areas of land that is also frozen over. So it's located in the Arctic Ocean, and it's roughly halfway between Norway and the North Pole, but it's a selection of islands. So when you next get your atlas out, definitely go and check it out. Now, believe it or not, around 3,000 people live in Svalbard, as well as a few thousand polar bears, but it is quite populated. Now, in the summer, you get temperatures of around about 3 degrees. So it's never, ever particularly warm. So it's around about 3 degrees here when I woke up. But that's what it is in summer. Here we are. So somebody's saying about it's from a very famous Philip Pullman's book. It absolutely is. And in the winter, it goes to -20, which I certainly don't think that I would particularly like to live there. Now, in the winter, Svalbard has 5 months of darkness. So the sun never ever rises. And so you have darkness all night and all day. And that phenomenon happens for around about 5 months of the year. And then in the summer, they have the total opposite. They have around about 4 months when there is daylight for 24 hours. Now, sometimes when you read things, it says 6 months of daylight and 6 months of 24 hours of daylight and 6 months of 24 hours darkness. And it doesn't quite work like that. A little bit like when we were looking at climate and we talked about the fact that you can't just be in an arid climate and then jump over and be in a tropical climate. It kind of moves gradually. It's a little bit like that when you're talking about this for the same reason. So we have 5 months of total darkness and 4 months roughly of total daylight. It does seem cool. What's it like for the other 3 months? Well, it's that blend. So you start to see a reduction. So if you're in the darkness period, you start to see a reduction. So you start to see slight periods of light. And then the opposite, when you're going through your 24 hours of sunlight, you start to then see periods of darkness. And the answer to that will be a little bit clearer when we look at why this happens, which is what we're going to look at today. But it's not like a light switch, because you're talking about science and the location of the sun and all sorts, which we're going to look at today. But that's the reason. But yes, you definitely, it would probably mess up a little bit with your body clock, because you'd wake up at 2 in the morning and you'd be like, oh, it's light, good morning. We often use light all the time in Europe in order to know when we should be awake and when we should be asleep. But the polar regions, this doesn't just happen in the Arctic, it also happens in Antarctica as well. And they're really unusual seasons. They're really, really very different. So the first thing I'm going to ask you, and I nearly showed you the answer then, is I'm going to give you 30 seconds to have a little think. Why? Why do you think this happens? Why do we, if we're in Europe, see spring, summer, autumn, winter? We see a slight change, don't we? So that it's getting slightly lighter of an evening. In the winter, it gets darker a little bit earlier. That might give you a little bit of an idea. But why in the polar regions do they see these unusual seasons? Does anybody know any reasons? I'm going to sit quietly and have while you have a little think. Right, so Jack says it's where they're positioned on the planet. It absolutely is. Is it to do with the Earth tilt? Is it to do with the energy that they receive from the sun? Is it to do with the sun not reaching them? Is it because of the tilt of the Earth? Wow, lots of you obviously were with me last week. So the question is, why do we see these periods of 24-hour light and 24-hour darkness? Well, there's lots of reasons. And so this is a diagram we've looked at before. We looked at it last term when we were looking at seasons. But one of the reasons is definitely because of the Earth's tilt. So the Earth's axis tilts an angle of about 23.5 degrees. So when we look at the Earth, we imagine that there's this imaginary skewer that goes through it, but it doesn't actually. There's no. If we talk about the Earth's axis, it doesn't really exist. If you go from up in space, you don't see a stick, an axis coming out of the Earth. It doesn't actually exist. But it's there to illustrate to you that the Earth is tilted and it rotates on its axis. And so as the Earth orbits the sun, which we know, different areas receive different amounts of solar energy. And we looked at this last term, didn't we? So we looked at the fact this is why we have our seasons and why people have particular climates, because it's vertical, it's tilted and it's not vertical. When the sun is hitting the Earth, it hits the equator. It's easier to heat the equator because obviously you've got the bulbousness of the Earth. Whereas when you're looking at the Arctic or the Antarctic, it's got more space to heat. Now, when the northern hemisphere is tilted towards the sun, so if you look at the diagram as it's coming around, it's rotating. And so if you imagine the sun, you can do this afterwards, either with yourself or with an orange. So if you get a grown-up to hold, I don't know, a tomato in the middle, and then you rotate it with an orange. If you tilt an orange and you move it around the sun, what you'll find is that there's going to be times when the northern part of the globe, or the northern part of your orange, is going to be tilted towards the sun. And then it's going to be, as it goes around, there's going to be times when it's going to be tilted really far away from the sun. Does that make sense? So if you just imagine it in your head, you've got your sun and you can see it on the diagram as you move it around because it's on an angle. When it's here, the northern hemisphere is tilting towards the sun. But when I come around this way, it's tilting away from the sun. So when it's tilted towards the sun in Svalbard, which is roughly between the 21st of March and the 21st of September, it receives more solar energy. And because it's receiving more solar energy, because if you think about that tilt, it's going to be the closest area to the sun. And so this is the polar summer, and this is it receiving 24 hours of daylight. So if you look on the diagram, it is the globe that is on the middle right-hand side. You can see that it is tilting completely towards the sun. And so because of that, that area receives 24 hours of daylight. And the opposite, if you go all the way round to the other side, to the left-hand side, you can see that the northern hemisphere, the Arctic Circle, is now completely in darkness. And you can see that the southern hemisphere is in light. And that's why you have this, one of the reasons you have this phenomenon of periods of time where you have complete sunlight and then periods of time of complete darkness. So anybody that worked out that it's to do with the axis and to do with solar energy, then you're absolutely right. Now, that means that Antarctica has the opposite. So when the Arctic is in its polar summer, the Antarctic is in its polar winter, and the opposite way around. And because we're in the middle, we tend to see, as I said, in the summer, increased daylight, and we see in the winter decrease in daylight because we're not quite, because we're sort of a bit north of the middle. We are not of the globe, of the earth rather, we are not completely ever in complete darkness or complete light. But that's why you have these special polar regions and these special polar seasons. Now, we looked last week, there's a little bit more to it than that. The Arctic tends to be slightly warmer than Antarctica. And both of them have really low precipitation. We talked last week about the fact that they are classified as deserts. But actually in Antarctica, it is colder. It can get as low as -62 in Antarctica. It never, ever, ever gets above freezing. Whereas in the Arctic, it sometimes can. And the other thing is, although it averages out at around about sort of 3 or 4 degrees in Svalbard, you can see summers getting up to 10 degrees, particularly due to global warming. Humans absolutely can live in the Arctic, and they do live in the Arctic. But this gets my next point is, why are they so cold? Why are the areas so cold? Can you remember this diagram from when we looked at the climate? Why are they so cold? So it's not only the axis, it's to do with what I've just mentioned. Can we remember? Well, as you can see here, when the rays of the sun are hitting A, it's very different to when they're hitting the areas of B, so the Arctic and the Antarctica. And it's to do with latitude. So can we remember this? So polar areas have high latitude. So these are the lines that go around the Earth. And so the further away you are from the equator, there's a bigger distance that the sun has to heat. And so that's why if you're near the equator, you tend to have higher temperatures. But places that are further away, if you can look, you can see it from the circles. Can you see? If you look at this little circle by A, it's quite a small circle. Okay, because the sun's rays are heating up a smaller area because of the nature of the fact that we're dealing with a sphere. But if you look at B, the sun's rays don't differ. And it's nothing to do with the fact that they have to travel. Sometimes students think it's because they have to travel a little bit further, but they don't, do they? Because if you're looking at B, B is technically closer to the sun. So it's nothing to do with the distance that the rays travel. That's something that some people get really confused about. Because even like if you see that tilt there, you can see that actually in theory, the North Pole is closer to the sun than the equator. It's to do with the sphere shape. So you can see it from the circle. A, the sun is coming and it's only heated. The concentration of the heat waves is heating a smaller area. And so that's why the equator is hot. Whereas because you're heating up a sphere, when the rays hit the North or the South Pole, because the Earth is curved, it's having to heat a larger area. And because it's having to heat a larger area, it means that these areas are cooler. Has nothing to do with the distance that it travels. Because some people, I think, forget that the fact that the Earth is tilted, and they think, oh, well, if it's like this, the sun's rays are going to hit the centre first. That's why it's hotter. But it's not, because the Earth is tilted. And in this picture, in theory, the Arctic is closer to the sun than the equator. It's nothing to do with that. It's to do with the fact that it's a sphere. And so the sun is heating a smaller area at A than it is at B. And that's why the further away you travel from the equator, the cooler it is. Does that make sense? And so that's another reason that they're so cold. So that's one thing. They're also really dry. So why are they dry? Because when we've looked at climate before, Areas that are generally colder in the winter, like Europe, actually have a lot of high rainfall. In fact, when we looked at the UK, which is pretty cold during the winter, we have piles of precipitation. Now, remember, I'm talking precipitation. I'm not just talking about rain. I'm talking about snow. I'm talking about hail. I'm talking about sleet. Well, why is an area that's so cold so dry? Because some areas of the Arctic and Antarctic receive less than 150 millimetres, so 15 centimetres, so like kind of about this of precipitation. Whereas London, and we know that London isn't the wettest area of the UK, but London receives about 60 centimetres or 600 millimetres. So why is somewhere colder so dry? Do you know? Any ideas? Have a little think. Why is somewhere colder so dry? Because surely you'd think there'd be piles of snow and that it would be always snowing, and you'd be able to walk along in the Arctic and it would always be snowing, and we think about Father Christmas and we always imagine all this snow in the Arctic, but actually it's really dry and we have actually a real limited amount of precipitation up there. The complete opposite of somewhere like here, which is less cold. Is it too cold to rain? Well, yes, it's too cold to rain, but it's not too cold to snow. So when we use the term precipitation, we mean rain, we mean snow, we mean hail, we mean sleet. So it might be too cold to rain, but why is it too cold to snow? There's got to be a reason, surely. Is it to do with cloud? There isn't a lot of rain, absolutely, but there's also not a lot of snow. There's less cloud cover. Is that the reason? Is it because of something to do with the water cycle? I'm loving some of these ideas. Is it to do with coastal currents? Wow. If you've got a huge coastal current, would you not expect more precipitation? It might freeze, but that's still precipitation, so that's a really important one. Is it to do with the fact that water isn't evaporating? Awesome, because it's not hot enough. Shall I show you? Shall I explain it to you? Well, it's to do with this diagram. So all around the Earth, the air is circulating, and we have the circulation of air. So we know that the hot air rises, then it cools, and then it sinks again. And so the air is circulating all the time, isn't it, all around the Earth? But the general theory is, from scientists, that the air is circulating in kind of 3 distinct cells in each hemisphere. So the circulation of air is circulating in 3 cells in each hemisphere. And this is called the global circulation model. Now, if this starts to get a bit complicated, don't worry. But you could also go and do some extra reading if you wanted to do with the global circulation model. Now, it's to do with, whoever said it's to do with cloud cover, you're right, because in polar areas, the air is generally sinking. And when air sinks, condensation does not occur, and so there's no cloud forms. And so this is what creates the really dry conditions. So it makes it look like the polar areas, as I've said, when we go and see Father Christmas, in films, for example, we have this view that there's going to be so much snow. But actually there is a lot of snow, but it's to do with the fact that the snow doesn't tend to melt. So the small amount of precipitation that you do have that does fall as snow, it doesn't actually melt, does it? Because it's cold. So although these areas do have lots of snow, that's not untrue, but they don't have lots of snow falling from the sky. So when the snow does fall from the sky, it doesn't melt. So it just builds up into layer upon layer upon layer of snow and ice. So when you look at pictures of these places, it's full of snow. But that snow's potentially been there for a very, very long time because it never ever gets warm enough to melt. So on the ground, you see lots of snow. But this idea that you'd go to the Arctic and it would be forever snowing in the sky is not true because precipitation is really, really low. And so it's very, very dry. And it's dry because if you looked at the sky, there is very, very little cloud cover. In fact, hardly any cloud cover at all. And it's to do with the circulation of the air. So if that's as much as you can take on board, then that's absolutely fine. Just understand that the way that the air circulates around the Earth means that in the northern and southern, north and south poles, the Arctic and Antarctica, there's no cloud cover. And although physically when you see it, it seems really snowy, it's only because that snow from 2 years ago hasn't melted. If you want to know more, then start looking at these 3 cells, this global circulation model. In polar areas, you tend to find the air is sinking, and therefore you don't have condensation like you have here. So definitely go and check it out if you want to get really, really into information. But if it's too much, absolutely don't worry. So that leads us to the next thing. How do you think people have adapted to living in 24 hours of daylight? How many things can you come up with of how you think that people have adapted to living in 24 hours of daylight? What do you think is going to be a problem, first of all? So someone was saying you'd wake up at 2 a.m. and think it was daytime. Probably, you absolutely would. So how do you think people have adapted? How do you think people have adapted to living in 24 hours of daylight? Yes, they definitely would have really good blackout blinds or curtains or shutters, because it would feel really, really, really hard to get to sleep otherwise. In fact, I reckon if I lived there, my children would say, well, I don't need, because my children very much look at whether it's light outside, and if it's light outside, it's not bedtime. So it definitely would have a real different view. You would absolutely have to rely on your clock, because your body clock wouldn't work as well, would it? Because we're used to thinking of dark and light. So there's definitely, you'd have to stick to a particular routine. Absolutely, you definitely would. Next one then. How do you think you would adapt to living in 24 hours of darkness? So we all need something from the sun that you're not going to get if you're living in 24 hours of darkness. You might use eye masks for sleeping in daylight, absolutely. How would you adapt to living in 24 hours of darkness? I think it might be a little bit miserable. Yes, you need to take torches around with you. Torches during the day, absolutely. What else might you need to do if you were living in darkness for 24 hours? Yes, maybe vitamin D supplements. Maybe you need to use far more electricity because you'd need more lights, absolutely. So really good case study to think about looking at this. And again, you could leave, after this lesson, you could go and look a little bit more about the human geography. So how people have adapted to living in Svalbard. You can absolutely get special lights to feel like sunshine. They're called sad lights. Seasonal affective disorder is where we feel a bit miserable when there's not much daylight. But yes, blackout curtains or blinds when it's 24 hours of daylight. People would spend more time, lots more time, I think, outdoors doing activities because they know that they have months of darkness to come. So I think it would encourage you, incentivize you to go outside and use more of that daylight, to make as much, use as much as you can of that daylight, because you know that then you've got to balance it off with that darkness. Another really important one for this is that you need to use a 24-hour clock, because if it's 6 on your watch, it's very hard to know whether it's 6 at day or the 6 o'clock at night. So they all would use a 24-hour clock. Now, 24 hours of darkness, you may actually move away during these months. So some people may actually move away, and a huge reliance, we got this, on electrical lights. And obviously you'd have to spend more time doing indoor activities because actually it would feel quite bleak. Don't forget, it's going to be incredibly cold as well. And so it would be spending far more time doing indoor activities. So that leads us to our next question. Would you live in Svalbard or not? So if so, why? And if not, why not? Would you want to live in those conditions? It sounds pretty cool. 24 hours of daylight, 24 hours of darkness. But would you actually want to live there? Yeah, lots of people probably go on holiday when it's 24 hours of darkness. It does sound kind of cool. However, the thing for me is it would be lovely if it's 24 hours of daylight and it was hot. So for me, I wouldn't want to live there because for me, I think I wouldn't be able to cope with the fact that it was never ever really very warm. But I'd be interested. I wouldn't like 24 hours of darkness. Why? It would be miserable, I think. It would be beautiful. 24 hours of darkness. Yeah, it would be really unusual. Can you imagine going to your home ed meetups and it's always dark? That would seem really strange. I like it because I'm antisocial. I like darkness. Yeah, so we do tend to get a bit kind of stay at home and get all cozy when it's winter. So it probably would definitely be a bit more like that. Yeah, you would be able to stay up really, really late when it's 24 hours of sun because you would need to go to bed. I wouldn't like it because I wouldn't know when I'm supposed to go to sleep. Jack likes the darkness. No, because I like riding my horse in the sunshine. I'd go for a month in the darkness. Yeah, lots of people like the dark. No, I don't want to be cold and freezing. I'd rather go to Spain. Yeah, really tricky, isn't it? Really tricky. But lots of people do live there. Lots of people do live there. Now, if you're looking for some extra things to be doing, it should be in the copy above or below. But go and do me a climate graph. So last term we looked at climate graphs, and also we looked at all of the things, if you were asked in a GCSE exam to explain a climate graph, all of the things that you would include. So what you can go and do is you can go and do the Svalbard climate graph, plot all of the rainfall, or the precipitation, should I say, plot on all of the temperatures, and then if you wanted to, you can then write an explanation using all of those things you need to include. So average temperatures, the range of temperature, average precipitation, the range of precipitation, and all of those things. And if you don't like writing, you could talk to somebody at home instead. So yeah, definitely go and check that out. And go and look at, back to this one, this is definitely something new that we haven't looked at before. But definitely go and look at the global circulation model if you're looking for some more complex geography. And I will see you next week. See you soon.